All right, let's go to Bermuda.
Oh.
Pink sand beaches, azure waters, charming white roof villas clinging to the hilltops. And when the water swirls around your feet and ankles, it looks like champagne. Oh, there we go. And we're going to go on a sailboat. This is Selkie of Morris 32 foot, crew of 4. And it looks like here we're going on a leisurely cruise to Bermuda, but no, we're going to race. That's me up on the rail there. This is about a 640-mile race from Marion, Massachusetts, up in Buzzards Bay, all the way to Bermuda, nonstop. And to make it interesting, though, we're going to do a race, and we're going to turn off GPS. Now, this means we've got to rely on the sun, the moon, and the stars for navigation. This is why I'm telling this story to an astronomy club. In 2019, I had the privilege of serving as navigator aboard Selkie, this Morris 32, as part of a crew of 4. You see me there holding my navigator's ruler. To the left is, in the back to the left is the skipper and boat owner. In the back to the right is our watch captain. And the guy in the white shirt is the bilge rat. So now, to you land lovers, you might think of the map of where to find Bermuda. There's a big white ocean with nothing in it. And on one side, there's the continent. On the other side, there's this tiny little island in the middle of it, the Atlantic. And you'll see it's not in the Bahamas, not in the Caribbean, it's in the middle of the Atlantic. And we've got to go all that way. But the nice thing about the rules of this race is the old saying that it's not the deep water that kills the sailors, it's the crunchy bits around the edges. This race and its rules accommodate that in that you can keep the GPS on. Let's see, do I have, oh, not yet. All right, you can keep the GPS on, get rid of that, until you leave the New England coast, and you can turn it back on as you're approaching Bermuda. So in terms of those crunchy bits, you do have the full benefit of GPS. But this is what a navigator's got to look at. It's not just a big white sheet of ocean. It's the Gulf Stream and all of its bends and meanders and eddies, and it's the wind. And together with this, you can take the parameters of the boat that you're sailing on and how it does with what wind speeds and which points of sail, and you can come up with an optimized route. And that's what you see here, that kind of curved blue line along the black line that's straight between the island and the continent. So it's not just a matter of finding that little speck in the middle of the ocean using celestial nav, it's a matter of staying on the optimized route, because you want to get that meander that's giving you an extra kick, maybe 3 knots towards your goal, and stay away from the part of the meander that's giving you a kick of 3 knots back towards New England.
John, are you doing recording?
Okay. It's got a broad reef system, so you don't want to get too close without knowing really where you are. So here's the key. The main instrument we're going to be using is texting. And it's not all that complicated. You can see the arc with numbers on it. You can swing this swing arm along the arc, fine tune it with the knob there at the bottom. I have one skipper that I sail with regularly who saw me practicing with a sextant on his boats just locally. And he was under the impression that, all right, I take a look, I use the sextant, I take a look at the sun, and I can look at it and know where we are. Does not work like that at all. Only thing you can see with the sextant is the angle between the horizon and some celestial body. So that's all you get to work with from this. Now, the other instruments you can use during this race are the traditional instruments, a magnetic compass and a knot meter. In this case, it's an electronic thing, but it will tell you your boat's speed through the water. However, because you've turned off GPS, some of the things you can't see are your boat's speed over the ground. So if you're wondering, did you catch that current in the right direction? You can't really know other than taking the long view with taking lots of sights with the sextant, because you can't see your GPS speed over ground. Another thing you can use is your wind speed. You've got a little anemometer at the top of the mast, and there's a little weathercock thing at the top that tells you what direction the apparent wind is coming from. So you know the apparent wind speed and you know the apparent wind angle. But because, again, since you've turned off GPS, you can't know the true wind speed and true wind angle. Just to know that, you'd have to have your GPS position. So this can measure the angle between the celestial object and the horizon to tenths of a minute of arc. So those of you who are not that familiar with astronomy, let's talk about degrees, arc minutes, and arc seconds. So in this context, a minute is not a time unit, it is an angular measurement. There's 60 arc minutes in a degree and 60 arc seconds in a minute. So if you're getting down to arc seconds, it's a very, very tiny fraction of an angle. And this device lets you get down to a fraction of a minute. And you can see that, I don't know, not everybody on the Zoom call can see, but I'm pointing at the bottom, and right off this swing arm, there's the knob with the numbers, and next to that, there's some other numbers. So you can get down to the, yeah, that's what you got. So you can get down to the tenths of a minute of arc when you're measuring the angle.
Just so everybody knows, if you have a question, I have a microphone. The people online, the people on the Zoom probably won't be able to hear the question you're asking. So if you have a question, let me know, and I'll bring this microphone over to you so that the people on the Zoom call will hear what you're asking.
Yeah, thank you, Chris. So here's my crewmate Vito using the sextant. This was actually taken a few years later. We tried to do this another Bermuda race 2 following years, but it kept getting canceled because of COVID. So we were practicing for another race, and he was learning to do some of the navigation. So you can see what he's doing. He's looking not up at the sun, but at the horizon. And you change the swing arm to get the sun within the sextant's view to come down and just touch the horizon. The other instrument I didn't mention that you really need is a watch. In fact, I had to know what time it was exactly to within a second the whole way there. So my watch isn't a fancy, expensive watch, but what I could do months in advance is check my watch to see how it's drifting. So I would know that, oh, after a week at sea, I need to add a second or subtract a second. And the only important thing is that it drifts at a constant rate, so you can predict it. So here's what it does. It measures the angle, as the sextant does. It measures the angle between some celestial object and the horizon. So you can imagine that there's some geographical position above which the sun is at the zenith, or whatever celestial object is at the zenith, directly above. And you're out here at that angle. So if you imagine this, you can imagine swinging a cone with this triangle so that it inscribes a circle upon the globe. And at any point on that circle, using the sextant at that moment in time with that same celestial object, you get that same angle. So you can see it doesn't tell you where you are, what your position is on the globe. All it does, it can begin to tell you that there's a circle on the globe and what its size and position is, and you know you're somewhere on that circle. So here's an example. You've got like 2 different sites for 2 different celestial objects, and they're each, that angle is going to be constant through that whole circle. So you could be, if you get 2 objects and you get 2 intersections, you're in one of those 2 places. But fortunately, you tend to know which ocean you're in on any given day. But the other thing you can see here is that this is a big picture. And if you're looking at your local area, corrections.
In progress.
The next few numbers are corrections to that. Is there a question online? Okay. Now some of the other numbers coming down here are from the tables, these books of tables, and some of them are derived. But ultimately, you're getting from this a line of position that you can put on a little mini map. Whoops. A little mini map that's kind of generic. And as you can see, I've had to draw my own lines of latitude on here, the 34, 35, 36 on the right-hand side, and the lines of longitude that encompass the area I think I'm working in. And so what do we have? There's this kind of line coming down at this angle was the one that was at that site. So you have an estimated position and a dead reckoning. There's a dot there. It says DR for dead reckoning. So that's what I thought I had as my position based on where I was before, how fast we were going, how long we've been going that fast, and what direction we were going. So I've got a position here's where I think I was based on all those things. Now I've got a line of position that's not right on top of it. So I'm going to take the shortest path and say that's where I think I am on that line of position. This was the second to last day of our race. Here's another one. And you can see here the GMT watch correction. At this point, I knew we'd been at sea for about 5 days, and I had to, what would I do? Add a second, take a second off. I had to take a second off. All the same types of calculations. You get a line of position. And this tells the story towards the end of the race. You see these 2 circles, the 50 nautical mile and the 35 nautical mile. And those are based on the Kitchen Shoals Light, which is just off Bermuda, in the middle of all the reefs. So you can see my estimated position. We got into the 50 miles. And we had agreed amongst ourselves, all right, we're going to try to get in within 35 before we turn on GPS. And you could see where I turned on GPS was right at the edge of the 35. At that point, I started to relax and had my first beer of the whole race. And here we are at the Royal Hamilton Amateur Dinghy Club at the end of the race with dressed ship and the Royal Hamilton Amateur Dinghy Club is the sponsor of the race at that end of the race. Whoops. And our actual final destination, whoops. I don't know what happened there. Anyway, I had a picture of the bar at the yacht club where we can truly be said to have reached our goal.
Oh, at the end of it?
Yeah, that was the end of it.
I have a question.
You got the mic? Let's get the mic. Marty had a question.
Yes, I had a question.
Let me get Marty here, and we'll go online.
Either way, it's fine. But just a quick question. How frequently were you taking readings as you were going? Is this like an hourly thing or just twice a day to see where you were at?
I would often, so the question was, how often did I take sites? I would often take one at a sun site at like 9-ish in the morning, 9:30, and try to take another one like mid-afternoon, 3:30 or something. And if the moon was up during the day, I could take a sight of that. There was more calculation with the moon because you had to deal with parallax. It's one of the few bodies close enough where you had to deal with that. And there were some extra lookups and some extra calculations to figure out how that's affecting your position.
And what other objects were you using besides the sun and the moon?
Just, I tried the stars,
Okay.
and I could not, for the life of me, bring a star all the way down to the horizon without losing it through the motion of the boat. What I would do with the sun and the moon is I would do like a really rough estimate with, putting my hand out at the end of my arm with a buffalo sign and count up how many times that was. And like, I'm about 60 degrees, put the swing arm there, and I didn't have that much to do. And the sun's a little easier not to lose, right? I thought I would have an advantage because I'm an astronomer. I know where the stars are. Could not bring them down to the horizon. When I got to Bermuda, I talked to one of the other navigators, and she said, "Oh, but that's the easiest part. You look up the star, find out where it is, and preset the sextant, and just adjust a little bit." So next time, I know. So there was one. Let's go to online, and then we'll go back to Albert. Who was online that wanted to ask?
Yeah, so I had a question. This is Jeff. So I imagine like, with the sextant, you get your GPS position or you get your actual, position and a true course, to go to Bermuda. Do you use magnetic declination and correct that true course to a magnetic heading and then put that and aim the boat on that magnetic heading? Or, do you need to have like a, declination angles like all along, the whole how do you get from a true course to Bermuda?
Yeah. Okay, I think I understand your question. So like, since I'm using the stars, I'm dealing with true directions, not magnetic directions, right? But the thing I'm doing with the stars is not to look at my direction. What I'm doing with the stars is to see what my line of position is.
Okay.
And yes, I do have to reconcile that because the instrument I'm allowed to use on the boat for my direction is a magnetic compass. So I can't use some kind of GPS derived instrument that's giving me direction. So I do have to reconcile that. And it's not only the difference between magnetic and true, it's the fact that that difference changes as you change your position on the Earth. You have a different variation between magnetic and true at one point, maybe at one point in the course, and then you would on another. So you have to be aware of that. Did that answer that, Jeff?
Yeah, it did. Yeah, it's that's what we do when we fly airplanes. Yeah. Thank you.
Albert, do you have the mic? I think you had a question.
Really don't need it, because I was going to ask a question on what stars were you using for night?
Oh, so well, that's still a good question. I'll ask, what stars was I using? And there's 57 common navigational stars, and they're the bright ones. But 57 includes the southern hemisphere stars, so there's less than that. But you know, I'm just picking a page at random here. We got some of them are not that well known, like Hamal, but then Aldebaran, Rigel, all right, Achernar, I think that's the wrong hemisphere. Fomalhaut, Enif, Alpharats, Pollux, Regulus, Acrux, again, I think we're in the south, Canopus, again in the south, Rigel, and so on and so forth. So most of them are things you've heard of, and they're all bright. One thing I did during the race is I had this big chart, and I'm going to hold this up to the camera for a moment so you can get a sense of the scale. This was, here I am. I'm going to show it to everybody here. Great big chart. We got New England coast on one edge and Bermuda down at the bottom. And I was using this to keep our, I think I did my dead reckoning on this because it's got the full context of where we are. For each sighting, I would use a smaller generic charts and then transfer that position onto this.
So I guess on average or minimum or maximum, how close was your dead reckoning to your line versus if you have any knowledge of how close it was to your actual route?
Yeah, so the question was, on average, how close was my dead reckoning to the, well, actual position? I'll have to say, I don't know what my actual position was. All I knew was where my line of position was, given whatever error I was bringing into it through my sight. But there were times when I was like 30 miles off. I thought, okay, wait a minute. I don't want to go up and tell my skipper that I'm 30 miles off. So usually there was something I could find. Very sensitive to time, because I was measuring it to the second. And imagine we're sitting here sitting still in chairs, but what we're really doing is moving at 900 miles an hour to the east. So you have to capture that time exactly when you've got the sextant so that the sun is just touching the horizon. You've got to capture the number on the sextant and the exact time that you're doing it, and be aware of the fact that you're using Eastern Daylight, not Eastern Standard, and conversion to Greenwich. It's like, if you're off by an hour, you're off by 900 miles. And if you're off by a few seconds, you can be off by maybe 30 miles. One of the things I did was I went up on deck, took 2 readings, wrote them both down, and then reduced the sight from one with the time from the other. And that had me pulling my hair out for a few hours because I didn't realize I was doing that. Al, just get the mic so everybody can hear you. Did that answer your question, Rita?
Yeah.
How close were you when you turned your GPS back on?
Oh, I don't know if you saw that one chart. I was right on the edge. I was right on that 35-mile circle.
Yeah.
So yeah, I was really happy about that. I didn't mention, we came in 4th out of 9 in the end.
Actually, I have another question, so I might just steal this for a bit. So when you say line of position, are you basically like drawing a line across the map? It's like I'm somewhere on this line?
Yes, that's all you can tell is you're somewhere on that line.
Ah.
So if you've done a dead reckoning position and the line is close to that, I would just, the method I used was one somebody named John Carl put together, where you just take the 90-degree closest line between your dead reckoning and that line of position, and that can be your estimated position. There's a running, what do they call it? There's another method of doing it that I didn't find as convenient.
Which end do I speak into this?
Okay, this is okay. So just listening to you talk about, taking these measurements on a pitching boat, I was just wondering how much is the inter-observer variability? I mean,
So
how much could you be off just because the boat is too pitching a lot and things like that?
yeah, question is, because of the motion of the boat, how accurate can you be in your measurement? It's not just the pitching of the boat can be an issue, but one thing you can do is sit at the center of the boat where the mast is, because the pitching is at its minimum there, right? But the genius of the sextant is it makes it possible to take a good reading in spite of all that going on. But the other things that are coming into play is, you got the time wrong, or you had it tilted a little bit when you thought you were at you thought the sun was touching the horizon, whereas if you tilted it into place, it would have been below, something like that. There's a lot of things you can do wrong. Really, the expectation is if you're a skillful user of the sextant and you get things right, you can be within 2 miles.
2 miles. Could you put
Which
it
on a
on?
big ocean is pretty good.
Yeah, no, that's good. So could you put it on a gimbal?
Is it on a gimbal? No.
No, can you put it on a gimbal to stabilize it?
I don't think it would do any better,
Okay.
right? Because, I mean, there are things you're doing with it. There's something called swinging it. So you want to make sure that the sun, like say you've got a sun, it's like a pendulum, and you want to make sure it's touching the horizon on its lowermost part of the swing. And so there are things you have to do with it where I think a gimbal would get in the way.
Okay. And one last silly question. How far were you from Bermuda Triangle?
Okay, so I'll answer the question with a question, right? The Bermuda Triangle is reputedly has 3 vertices, right? One is Bermuda, one is Miami, and one is San Juan, Puerto Rico. Why doesn't anyone ask that question when you go to San Juan or Miami?
Yeah. Yeah.
Al's got a question?
Sorry about this.
You take your readings with the sextant and you keep track of your time, and then you go to the book and you look that stuff up and it gives you your position.
Yes. Yes, what you can do, the sextant is, the nice thing about the sextant is once you have dialed it in, as long as you've got your time figured out when it was that you dialed it in, you can at leisure look at your sextant and that number is still going to be there. So you got the time right, the sextant you take down, all your books out, work with the compass and the ruler and calculator.
So you mentioned the calculations and subtractions and such. I guess what are some examples of those, or like what they represent?
Can we get that PowerPoint going again? Okay, can you guys on the Zoom call see it? I don't hear anything. All right, so the question was about the subtractions and the additions. So here is the site reduction sheet. And so here we've got a dip, and this is because you need to make a correction based on how far above the water your head is when you're taking the measurement. That's the first thing. The semi-diameter of the sun. So the sun is about 30 minutes in diameter. And that changed a little bit depending on how far away, what time of the year it is and all that. So you have to take that into account. What is the semi-diameter of the sun right now? I don't call it radius because radius is used somewhere else in this process and to deconflict it. the global hour. And so you start seeing things here. You've got an assumed position, a longitude and a latitude. You come up with an assumed position, and it's not your dead reckoning position. It's somewhere on your little map that's going to make it easier to do calculations. Because the table you're looking up in has only even number, flat number of degrees. And you got to give it a number of degrees that doesn't have any fractional part. And your assumed positional longitude, to make it easier on yourself, you're going to give it the same number of minutes of arc as your Greenwich hour angle here. So you can start to see what you're, and it tells you on this sheet, subtract this, add that, and so on and so forth. And you end up coming up with an intercept and an angle of your line of position that you can put on your mini chart.
Do this for relaxation. Sounds like homework.
Well, it's a different. Okay. I don't know if you guys heard Chris ask me if I do this for relaxation. That's kind of my response when I hear you guys are doing photo imaging.
Yeah.
And you have to reboot your telescope in the middle of the night. Any other questions online? Speak up if you've got a question online.
Bob, I don't know if you're asking a question, but you're muted.
Yeah, Bob's muted if you're asking.
Mute. Yeah, hi. I inherited a sextant from my dad, but I have no idea how to use it. And how would you recommend me getting a primer on how to go about using it?
Oh yeah. Let me see if I brought this book. I don't think I did. There is a nice accessible slim volume. I think it's called Celestial Navigation in Practice or something like that. I can follow up with you if you'd like. Write me a note write me an email, and I'll get that.
I will do that. Now, another question is in this race of 9 other participants, how do you know the other people don't have their GPS on the entire trip?
That's a good question. When you get to Bermuda, you'll notice that I had this big chart. I also have a portfolio full of these site reduction sheets with all my calculations on it and all the plotting sheets that I used day by day to come up with our position. When I did get to Bermuda, I was audited to make sure that I really was using celestial navigation methods, as were all the other, especially if you're placing or could be placing. Since we are fourth, we're close enough to the top where they definitely had to audit us. I suppose if you're last, maybe they don't care. But even then, if somebody, somebody above you in the ranking is disqualified for some reason, they might want to know. So you got audited at the end.
Okay. How did you get back? Is same method or just GPS all the way back?
Well, yeah, coming back, let me say first, this was another adventure. On our way to Bermuda, now it's a sailboat race, so we can't use the engines, but we could use the engines to charge the batteries. So we were about 100, 150 miles out from Bermuda. And we were using the engine to charge the batteries. The engine died. We're like, okay, we're a sailboat, we're in a sailing race, we'll just keep sailing. We could not get the engine running again. We crossed the finish line in the middle of the night. We had a towboat waiting for us who towed us all the way around the island into the harbor. And we had some decisions to make. The skipper was, he lived up in Massachusetts, he lived up in Boston. So he couldn't really imagine flying back and forth, talking to mechanics, getting that working. And I don't think he trusted the mechanics that were there, and it was very expensive. So we decided to sail back without an engine. And we didn't need to go without GPS on the way back, but it was helpful to have that confidence that, hey, if all else goes wrong, at least I can do that.
Yeah.
So we ended up deploying solar cells, doing a thorough energy audit, and going without refrigeration. You know, we loaded up with like ice. We had an ice box and put ice and dry ice in it, and had to ration power to things like the radar and those times when we use it, and to the chart plotter and that. But we, you know, we had 4 people aboard, each have a phone, they all have GPS. You know, there's no chance, almost no chance we were going to be without GPS on there. Took us 7 days to get back. No motor.
That was a
How many days?
very fascinating discussion. Appreciate that.
Yeah. How many days did it take you to get down there?
Took us about 5 days to get down.
5.
I think we did well getting on the meander of the Gulf Stream on the way down.
Were you able to see the stars the entire time?
You know, we had good luck with the weather.
Okay.
Yeah, I was worried that we may have to go a long time, dead reckoning, without being able to see the sun, the moon, or the stars.
Okay.
But we had good luck with the weather.
Was there a point, if the weather, not that it turned foul, but if you couldn't see, you know, navigation things in the sky, was there a point at which the race would have been called? Or
I don't think so.
Okay.
I don't think so. Because you could dead reckon all the way there, and
okay.
you can always turn on GPS for safety reasons. So if you
Okay.
if you feel like the reason we turned off GPS is that there was a class defined by the race rules that lets you turn off GPS, and you get a benefit for doing that, for participating that way. You get a 3% time benefit in your elapsed time. So this is a 100-hour race. If you do it with Celestial and you get to the finish 100 hours later, you get credit for getting there at 97.
Oh. Wow.
So that can be a big deal, and that could bump you up in the rankings.
Okay. I think maybe a couple more questions and then.
I'm curious when the sextant was sort of invented and how long this general site calculation method's been used, if you happen to know the history behind it.
Oh, well, this something like a sextant or a backstaff,
Yeah.
things like that have been around for hundreds of years. I think the assumed position methods that I'm using has probably been around since the mid 20th century. I don't know. My dad was a navigator on a B-17 in World War II, so I don't know if he used this method. But you'll notice these tables, site reduction tables for air navigation, but everybody uses them for sailing.
They used it on the bombers because the bombers had an asphodel.
Yeah.
Yeah. Look at it at night. Navigate with the
Yeah.
Yeah. I know the Mercury and the Gemini astronauts used celestial navigation.
Yeah.
They didn't trust ground control. I mean,
Yeah.
they learned celestial navigation because they expected ground control to not be reliable.
Any other questions online?
This is not a question, but this was wonderful. Must have been really exciting. You mentioned the importance of time, and I just
Yeah.
want to recommend a book to this audience. It's called Longitude by
Davos Sobel, right?
Davos Sobel.
Yeah.
Yes, yes.
Yes.
It's a wonderful book. It's
Wonderful
small,
book.
one sitting read.
Interesting.
Yeah.
Yeah, that's good. Yeah, thank you. Dean, thank you. Really,
Yep.
this is.
Thank you, everyone.
Yeah.